In this video, we will introduce ourselves to vectors. Okay. So before we talk about that, let's take an example. Suppose there is an island, okay, and on that island there is a pirate, okay. There is a pirate living on this island, and he wants to find out the treasure. Now this treasure is somewhere here. It is a hidden treasure, okay. It is below the sea surface, so he cannot locate it on just by looking it on the surface of the sea or ocean, whatever you call. This is an island. Now he wants to find out this treasure, but he doesn't know how to search for it. So he gets an information that this treasure is some distance away. Let's call 50-kilometer distance away. It is 50-kilometer distance away from this island, and it is in northeast direction. It is in northeast direction, right? Now tell me, to locate this treasure correctly, does he only require this distance information, or only requires the direction information, or he requires both of them? So see, if he only got the information that the treasure is 50-kilometer away from this island, then he can go in this direction, or maybe in this direction, or this direction, or this direction, so on. He doesn't know which direction to go. If he goes in this direction, he will not be able to follow or find the treasure. Here also he will not going to be find the treasure. So these directions are of no use, right? But yes, 50-kilometer he can go there. Okay, but along with 50-kilometer, if he knows the northeast direction, so he can go like this, 50-kilometer in this direction, go below the surface of the ocean and find out the treasure. Yes, he can do that. Now what if he knows only the direction? So northeast direction he has to go, but he doesn't know the distance. The distance is not known, that it is 50-kilometer. So what he will do, he will go there, he will search in northeast direction. See, there are many distances, right? 0 kilometer, 10 kilometer, 20, 30, 40, and so on. How many times he will check that, right? So both the magnitude, that is this value, as well as the direction are needed. So what does the 50-kilometer signify over here? 50 kilometers tell you about the magnitude, that is the distance of that particular pirate that he has to go, and northeast direction tells about the direction. That's it, direction. So both the informations are needed for us to clearly locate this treasure. Now the quantities which have both this magnitude as well as the direction information are called vectors, right? These are called vectors. So I can write the vector like this. From here to here I will put an arrow. This is a representation of a vector. So I am representing a vector with a simple line from here to here and with the arrow. This head represent the direction of the vector. It is in this direction, right? So you just simply draw a line and put a cap, or you can say it is not, it is a head, right? This is called as head of the vector, and this one is called as tail of the vector. This is called tail, this is called head. Okay, so this is a representation of vector graphically. Now the length is of this vector, or this arrow is thus signified that how much magnitude it has. For example, 50-kilometer length means the length of this vector is 50 kilometer. See, you just take a scale. Usually we take a scale. For example, 10 kilometer means 1 centimeter. So if I draw the line of 5 centimeter, that means it is 50 kilometer. So it is difficult, right, to draw the length of 50 kilometer on this board. So we cannot draw that. So we just draw it like this, 5 centimeter or whatever scale you can use. Okay, just like you see on maps, right? On maps you will see 100 kilometer is equal to 1 or 20 centimeter, like that. Okay, so this is how you represent. Now in this case, this particular vector is called as a displacement vector. In this case it is called as displacement vector. So I will write this vector, you can say, is a displacement vector. right? But the vector can not only be of displacement, right? It can be of any other quantity. So it shows here the displacement of y from here to here. This is what it shows. But vector cannot always be a displacement vector. It can be any type of vector. It can be a force vector. Suppose there is a block on this surface and there is a force applied. Now this is a force vector. It does not show, now in this case it does not show the displacement of this block. It shows the direction and magnitude of this force vector. The magnitude will be in Newton. Here the magnitude will be in meter, kilometer and so on. So here you can visualize, okay, this has gone from here to here. But here the force is in this direction and magnitude is 2 Newton. It does not signify that it is going in this direction displacement, right? It does not do that. Electric field is a vector, magnetic field is a vector. So all the laws that we will study for vectors are followed by all the quantities which are vectors. Okay, right? Now we have shown how the vector look like. The magnitude is given by the scale of appropriate scale. If 1 kilometer is 1 centimeter, then 50 kilometer is 5 centimeter. That scale you can use and show this vector like this. Okay. Now what if the treasure was somewhere here? What if the treasure was somewhere here? Then how the person who is telling the information of treasure will communicate with this particular pirate? Will he say, is it in northeast direction? Of course it looks like in between north and east direction, right? So if you don't know, this is north direction, this is east direction. In between you cannot say, right? Because see, this angle is 45 degree and northeast means exactly in the middle of north and east. Now it is not exactly in the middle of north and east. So maybe this is the direction. But how will I know this? I cannot come up every time with a new name to tell about this direction. So what I will do here, I will mention the angle theta that this vector makes with the positive x-axis and I will mention that angle theta. That will do. So here for every vector, what you do, instead of writing the direction like northeast, north, south, what you mention is this. You mention the angle theta that this vector makes with the positive x-axis. That is what you have to do. That's it. So here along with the magnitude, that is the length of vector, you should mention the angle theta, and angle theta will give you the information about the direction of that vector. So you can see from here, if theta is equal to 0, then what is the direction? The direction is going to be the east direction. If theta is equal to 90 degree, the direction is going to be the north direction. If theta is equal to 270 degree, the direction is going to be the south. And if theta is equal to, again, 180 degree, it is going to be the west direction. So you can map all the directions by the information of angle theta. If I know angle theta, I can map all the directions. All of the directions I can map, right? So that is what I wanted to tell you in this. So remember, if you want to specify a vector, you write the line, put the arrow and this head, and mention the angle theta that it makes with the positive x-axis. Don't mention this angle. This will be 180 minus theta, not this, but this angle theta. It can be acute as well as obtuse. Suppose a vector is like this, then the angle that you will mention is this theta, right? Because it is the angle it makes with the positive x-axis. So this is how you show the vectors. This is how you show the vector. Now, one more thing that I want to talk about is of equality of vectors. Okay, so let's talk about that. Equality of vector and how I represent the vector analytically. Let's do that. Let's see this. Suppose I have a vector like this. Now how will I write this vector? See, first of all I will mention this with a p. Okay, let's say this letter p represent this vector. Now to show that this is representing this vector, you write a arrow on top of its head. Now this arrow is pointing towards right. always, even if the vector is like this. For example, another vector is like this, and this magnitude we say q, then you mention again like this. It doesn't matter where your vector is pointing, the notation will remain the same. The the alphabet, and on the top of the alphabet you put an arrow in the right direction as well, always. Not so q with the arrow on top of its head, which points in the right direction. Or you can say q dash, or you can say q dash, or you can say here as well p dash, right? It doesn't matter, you can put arrow or dash, no problem. Now in some textbook they use bold letters because it is very difficult now to type this p with the arrow on top of its head. It is very difficult to type this, but that's why the people will use bold letters in textbooks. Now here we will use the arrow. Now two vectors are said to be equal if their magnitude and the direction both are equal, right? This is called equality of vectors. Equality of vectors. What do I say? What do I mean by equality? Two vectors are said to be equal, if they have same magnitude and direction. If they have same magnitude and the direction, then these two vectors are going to be same. For example, if I have one vector like this, I will call this as a bar, and another vector with the same magnitude, b bar, and let's say these lengths are same and the angle that it makes with the horizontal is also same. That means the direction is same, right? Now I can see theta is same, a bar magnitude, b bar magnitude is same. By the way, how do you represent the magnitude of a vector? Just you write like this, a bar, and if I put the modulus sign, that is two straight lines parallel to each other like this, is equal to the modulus of vector a. So a bar mod is going to be a. This is a notation, right? So now a bar has angle theta with x-axis, positive x-axis, and b bar also have a angle theta with the positive x-axis. Both have same direction, right? Now can I say if I have a vector like this, p bar vector, and let's say this angle it makes with the positive x-axis is theta, can I say if I just shift this vector towards right like this, is it going to be the same vector? The answer to that is yes. It is going to be the same vector because the magnitude of p here is going to be the same. I am not changing the length. I am not stretching this or compressing this. I am not doing that. And the angle that it makes with the positive x-axis still is same, that is theta. So I can translate it. From here you can say that the vectors do not have location. They do not have any position. The vector can be kept here or can be kept here. It is having the same meaning. If I keep it here or here, it doesn't matter. If I keep it down, for example, if I translate it downwards like this, it doesn't matter. If unless and until you change this angle, it doesn't matter. I can translate it like this. The angle theta is same, magnitude is same. This is the same vector. If I take this vector outside like this without rotating, see, I'm not rotating this vector. If I rotate this vector, what will happen? This angle theta will change. So I don't want to change that. I'm going to keep it like this. So if I take it outside, the angle it makes with the positive axis is same. If I go inside this plane, it is going to be the same. I'm not rotating, or neither I am stretching or compressing, because in that case you will end up changing the magnitude of the vector. So we don't do that. Now that means you can translate the vector any way you want, and we will see in a free body diagram in the Newton's laws of motion that it is very essential that you learn this skill to translate the vector from one point to another point. It's very important. Okay. Now this is all about equality of vectors. Now there is another operation that you can do on vectors, that is by multiplication of scalars. So I think I will discuss it in next video, because otherwise this video will become more longer. Okay, thank you.